And we're back for our next up Christmas special, holiday special of all things 3D. And in this special holiday episode, we are going to cover your new stereolithography printer. Our printer selected for today is a good friend of ours printer out of Santa Barbara. It was a successfully kickstarted project called the LittleRP. So if you haven't checked it out, it's called the LittleRP. I think you can find information at littlerp.com or thelittlerp.com. And it's a little unique. It's a stereolithography printer, and so it prints a photopolymer resin. Basically gets loaded into a build tray here, and it's light sensitive. So when UV light exposes the photopolymer for a certain period of time, the resin hardens. And so what this particular printer does, so you've probably seen this, you're familiar with it maybe in the Form Labs machine or another stereolithography printer that utilizes a laser to actually expose the photopolymer to the UV light and cure it with a laser. This is unique. It actually uses a standard off-the-shelf DLP projector as its light source to expose. So it actually projects light here using a projector onto a mirror up through the vat up onto a plane of material and exposes layer by layer, one layer at a time. So instead of having to wait for a laser to hit every single part of the material you want to expose, it actually will expose all the material at once on the layer. So it's kind of a unique design, and a lot of pioneering has been going into this over the past year or so. And special guest joining us today is the father, we'll call him, of a piece of software that's pretty much the go-to piece of software out there called Creation Workshop, and his name is Steve Hernadez. Welcome to the show, Steve. Again.
Hey. Hi, Steve.
Hey, he's in his elf costume.
Having me back. It's good to be here.
Oh yeah, great to have you.
One of the 3D helpers.
Yeah, and so Steve is going to run through. He's going to help us get this LittleRP. So Brad Hill, the creator of the LittleRP,
He'll be joining us later.
He'll be joining us in a little bit, and he was the inventor or the creator, I should say, of the LittleRP, which is a do-it-yourself SLA printer, but it's a DLP SLA printer, and so you can often find Steve or Brad both in the Build Your Own SLA forums, which is Steve, remind me, it's buildyourownsla.com. Is that right?
Yes, that's correct.
Buildyourownsla.com, and there's a great forum resource there with all kinds of people that are building these machines or commercial machines. Actually use his forum as the forum to have dialogue with the people that are building them.
So Chris, before we get started, if you know behind you, you've got a Form 1. What's the difference between that SLA printer there and the LittleRP?
So like we were saying, is the Form 1 uses a laser to expose the material. So that's one thing. They have proprietary build trays as well. And let's see, what else does it have? It's kind of got its own software that is proprietary to the Form 1. So it kind of you're kind of cornered into using Form Labs software. Whereas this open source design, obviously hugely popular has been the Arduino and all these 3D printing applications, but the Arduino is also the backbone of the LittleRP. The LittleRP also uses kind of a standard extrusion slot piece of aluminum for your build tray, which most of the parts on the machine are laser cut melamine coated MDF, or I guess they just call it melamine, and some 3D printed parts, so most everything is ABS. And then the idea was a standard Petri size as your actual build tray. And so this Petri is, while it is somewhat of a standard Petri size, there is something special to note about it, is there's actually a solar film on the inside that's used mostly for coating solar panels, and it's silicone. And so what that allows it to do is when the build tray is releasing, the material that's been exposed can easily break away from the bottom, because you're actually, they call this what's called it's a top-down printer, right, Steve?
Yeah, no, actually, this is a bottom-up printer.
Bottom-up printer, thank you.
Bottom-up printers definitely have some issues in releasing the currently printed slice from the build platform. The top-down printers have some other issues with printing. So, like what you were just talking about, that Petri dish has a silicone-coated elastomer on it called PDMS, and that definitely helps release the current slice onto the build arm. In addition, so the LittleRP can actually work in two different modes here. I'm catching a little feedback. So it can work with the tilt mechanism or work without the tilt mechanism, and I believe that Brad offers the tilt mechanism add-on to it.
Right. So what he's saying, this particular model here, so bring me up here, Mike, is this particular model features the tilt mechanism, so what Steve was saying is some variations of printers do not have the tilt mechanism. However, the do-it-yourself community, because there's been some possible intellectual property, we're not really too sure about it, but the do-it-yourself community, obviously, since it's not commercially available, has implemented later on the tilt mechanism, which just makes the build tray be able to release from the model that much easier, and so you can actually increase the size that you're building on an SLA printer. So SLA printers excel. They're exceptionally well suited for small, highly detailed, fine feature parts. And so I have some parts here. Is there any way we can show these off?
Yeah, let's go to this camera here.
So let me. I'm just gonna pop in front of the camera and see if I can put one up, and you can see.
Yep, a little tough on the focus there.
Yeah, come back.
It's kind of hard to see.
Getting there.
If we had a macro mode or something, we might be able to show it. Is any of these in macro mode?
Go to the Blackmagic is manual, so
Let's see.
Go back to that. Yeah, actually, I would. Actually, come back to here, and because it'll be zoomed in right here. Right here. Go stare at there.
Yeah, let me just come back around here.
There you go.
And
now you can see.
So you can see it's really well suited. So imagine trying to print at 50 microns or 100 microns and get these little teeth features on FDM or FFF technology, because you're limited by basically your minimum contour size, how fine you can print or squish down that melted plastic, whereas this is limited by a different set of variables, which more has to do with the viscosity of materials and some other things that are actually beyond me. So
right, also the optic path of the projector and the number of pixels that you've got inside your projector resolution is one of the prime limiting factors.
Got it. So Steve mentions one notable thing is the more high definition your projector is in this, obviously the finer the resolution you theoretically would be capable to do through this process. So basically the printer setup, so it has all of the features, and I think this retails for what, $900, and then you bring your own printer, or you bring your own projector, which you can buy for $300 to $500.
Yeah.
Ah, very nice.
I guess we'll find out when Brad gets here what he's going to be selling it for retail.
Right, but it was a Kickstarter campaign, and these were kind of part of that whole pilot program. And the next thing you're going to obviously need is not just a printer, but you're going to need material. Just like the FFF printers, you got to have material. You can't just print from nothing. So it doesn't come out in weed whacker line. It comes in a bottle. And remember, all of this stuff is light sensitive. So you want to keep it in a cool, dark place. Even though it's in a bottle, you probably want to keep it somewhere kind of like contained. And one thing that I have read on all the MDF sheets is you want to make sure you're wearing at least gloves, because you can actually develop an allergic reaction to this stuff over time. So even though you may not be sensitive to it now, over time, the more you expose yourself to it, you can develop an allergic reaction, break out in rashes and stuff, so it's no good. And so you definitely want to be careful when you're not only handling the material, but you're handling parts as well. So after we're done with the show, we've got to make sure we go wash our hands. So that's another part about SLA printing, is the parts themselves, even though they're fully cured, and these have sat in a salon nail bed to cure them even further with UV, you still want to make sure you wash your hands after you handle them, just to make sure that you're limiting your exposure to the chemical.
Great.
Yeah.
So Steve, we're going to go ahead and pull up the screen with the software, so maybe you can give us an overview before we get started in pulling something into it,
Sure.
and also getting it set up. So let me go ahead and do that right now.
Sure, we could walk through some of the process here and getting this set up for the LittleRP. So let's see. Okay, so we're taking a look right now at the machine configuration. So let's go ahead and create a new machine configuration for the LittleRP. Let's just call it LittleRP. All right, and then from the drop-down on the upper left there, let's select it. All right, so the build size refers to the image that's projected onto the build platform. And if I'm not wrong, actually, let me check my settings right quick here. I've got 60 by 45 by 100.
And if you want more in-depth videos as well, I will mention Brad Hill does have some videos up on the LittleRP website under the support section. He does have a couple of really great videos, so those can kind of be complementary to this tutorial as well. So
yes,
on to the next one.
We did some good walkthroughs there. All right, so it doesn't look like you've got a projector plugged in, so you might want to go ahead and plug that in as well, so we can.
Yeah, we definitely will.
And then in the meantime here, we can go over to the machine configuration and click the configure button there, so we can select the correct COM port.
So machine configuration?
Yeah, that configure button right there.
Okay.
All right, so let's see what we've got. Guessing it's COM6.
All right, let's try it.
For the LittleRP, he's using a baud rate of 9600 because he's using gerbil.
And yeah, and so this is a really important one for those of you that haven't gone through this step before. I had never seen this before, or I had never, I thought that probably it was the standard one, but this is notable for the LittleRP. You want to make sure you set that at 9600, otherwise a lot of your stuff will not work properly.
Right. Now it's interesting to note at this point that a lot of these LittleRP and all these other DLP-based SLA machines, they all use identical firmwares to the FFF FDM printers. So you can pop in your copy of Sprinter or Marlin or Gerbil, and we're really just using the Z-axis to do the lift for the machine. And then we can also repurpose things like the X and Y axis for other axes like the tilt mechanism or sliders, wipers, things like that.
Oh, okay. So well, that's good to know. Okay.
Right. So let's go over a couple things here. The output resolution is automatically filled in for you. Well, we still don't have the correct available display in there yet. Under machine controls on the center here, the kind of right-hand side, the LittleRP has a tilt control and a Z-axis. So let's go ahead and do both of those. And let's also click on manual G-code.
Can I interrupt for just a moment? Because we're feeding this into my streaming broadcast system and he's monitoring the screen, I cannot hook it up to the projector.
Ah. All right.
Will that be a huge problem?
Well, we're not going to be able to start a print if we don't have a projector configured to this, but
That's
we
okay. Maybe we can switch to you at that particular point.
all right, we'll kind of fake it for this point. So let's
Sounds
just
good.
take your main display and put it into the configured display slot. So on the left-hand side there, you see available displays. Now, normally you'd see at least two displays, your main display for your laptop or your desktop, and then the video display device that you're using for your projector mechanism. So you'd want to select, I suppose, the secondary display normally, and then click the plus button to move it over to the configured display side. All right. So let's also click on the checkbox for projector control. It's on the center, and then also manual G-code in case we want to feed it some manual G-code commands.
All right.
All right. Click apply here, and I think that should be enough to get us going at least. All right, let's go back to the 3D view, and all right, as you can see, now that we've chosen the machine size and the build size, it's actually adjusted the build volume to show the correct amount for this LittleRP machine. So
That's right. Yeah,
up at the top
about
toolbar, next to the save icon, you can click the connect button. So you can press escape right now. So what's happened is, since we're using our primary display, it's kind of gotten us confused. Just minimize that for the moment. So if we had been using two different displays, that would have actually shown a full screen display over your secondary display.
Right.
All right, so now we're ready to load up a model into the build area here and make some adjustments. So let's click on, actually, that's save.
Whoops.
I'll click the folder icon there, and let's go find a model to load.
Go under objects. What should I load up here?
Not responding. Of course, that's got to happen during the demo.
Of course.
Well, it's trying to connect to the OneDrive to Mike's OneDrive here.
Yeah, I give demos all the time, and you know, it can be tough sometimes.
Every environment is different. But after you get it all set up and you've done this workflow enough times, what I've found is that it's pretty straightforward and it works pretty well.
All right, actually, if you want to switch to my screen right quick, I can. I've got Creation Workshop loaded up. Let's see here. Oh, you're relaunching it. Okay.
So have you been printing on your LittleRP?
Oh yeah, definitely. I love this guy. It's actually probably one of the easiest printers that I've got here to use. And you know, since I do a lot of development with the Creation Workshop, I got a house full of printers at this point. I need to kind of thin the herd out a little bit. I've got 4 different FDM machines and 1, 2, 3, 4, 5 SLA-based machines. And I'm working to build another SLA, laser-based SLA, and then another laser-based SLS that I'm adding into the software right now. So I'll have to tell you more about that later.
Wow. Awesome.
So actually, I support laser SLA and then laser SLS through some specialty hardware. So you were talking about the Form 1 machines here before, and it's interesting to note that it uses a laser, usually around 200 microns or so in diameter, to basically rasterize some of these image slices. And it's a little bit different than what's going on with the DLP, which can expose an entire slice at a single time.
Right. Yeah, instead of doing 200 microns at a time, in a contour, almost like FDM or FFF.
Right. It's sort of like a very fast FDM.
Yeah, and I can imagine on a large scale that eventually DLP will be the way to go, because for large objects, it's definitely much faster, I've heard.
Definitely. It doesn't matter if you print, 1 object or 10 objects, the layer time will remain constant, unlike SLS or SLA scanning galvo-based mechanism.
So I think we're loading in an ELF, according to, I think Mike just loaded up an ELF here.
All right.
Let me see if I can show it off. Yeah, so I was pleasantly surprised how easy it was to get up and going with my LittleRP. I was certain that it was going to be even more tinkering than most FFF, and it was going to take a long, long time. And I have had a little trouble. I really love those guys over at Made Solid, but I've had a little bit easier time with the Maker Juice. But it could be just my settings. And
yeah, it's all in the settings. Every single different resin is a little bit different. So,
right. So look who's here!
Yeah,
the creator of the LittleRP just walked into the studio. So Brad Hill, he's going to join us. Hey, how's it going, Brad? What's happening?
Hey, how's it going, Brad?
All right.
Welcome.
Over in outer space.
Yeah. So Brad just joined us all the way from Santa Barbara, and he's the one that designed this whole printer. And he's going to. We just kind of talked about how the printer works, and we were just getting into how the software, how to configure the software.
Okay.
So the first thing I notice here is my image is too large, Steve. So or my STL is a little too large, right?
Right. So what I've done here is, you see all these exclamation marks. Well, that's kind of indicating that your model is extending off the edges of the build platform. So you don't try to go ahead and do anything stupid like printing a model that's too big for your printer. So what you're going to have to do is select the model, and it's already selected as indicated in green, and then go over to the scale tool on the right-hand side there, and then under the top box where it says all, I guess choose like try 50%, and then we'll click.
Type in 50
there. Yeah.
Boom.
Boom. There you go.
There it is.
Looking good. All right.
And probably we probably don't need to do much more, but there are the options, it looks like, to add multiple objects, get some info about the selected object, move it around. So here you could probably, it says put object on the platform. This one here will center the object. Oh, but it also centers the Z, right?
It centers the Z there as well, too. So just put it back on the platform.
Put it back on the platform.
And then if you've got multiple objects in there, there's an auto-arrange function as well, so it'll lay them out on the platform for you.
That's pretty nice. We've got a mirror function. You just saw the scale. We have a rotate. And then some different view options that let you view kind of advanced parameters, like, the what it looks like on the inside.
Yeah, there's a debug log console. There's 3 different views for selection types. There's also kind of an X-ray mode, so you can basically see inside the object or if there's interior geometries. And after you slice the object, you can actually see the individual slice in 3D.
So I went over here and what does this plus button do?
Okay, well that just basically opens up a panel on the left-hand side to show some more tools. And the only tool that's in there right now is support generation. So if this object needed to be supported, and I don't think it really does, you could add automatic supports like the bed of nails, or you could add manual supports, single support at a time, and drag it around the build platform bed. So right there, you just added some bed of nails. So it just basically created some supports on a rectangular grid and just shot them upward to intersect with the object.
Wow. And then it looks like there's 3 different choices for the automatic support generation. So it looks like bed of nails is one, adaptive, and adaptive version 2.
Yeah, I would go with adaptive version 2. It actually will take a look at the geometry of the object. I got to warn you, it's a little bit slow at the moment. So don't click on it unless you want to wait for a little while. But what it does is it looks for low-hanging portions of the object, and then it will automatically generate supports underneath those unsupported regions. And then you've alternatively got a minimum gap distance. So even though it might hit the center of an unsupported region, you could say, I want a support no more than X amount of millimeters away from that. So it'll sort of put it on a pseudo grid for you, but it'll also make sure that it hits the low areas. Now, another interesting thing here is some of the manual tools that you might want to take a look at. So at the top there, it's got a thing called manual. Nope, go down. Sorry. Under support generation, you see where it says generating?
Yeah.
Okay, go up right there to the right and down a little bit. It says manual. That button right there basically will show downward-facing polygon areas on your object. So if you were actually dragging around manual supports at this point, you could play around with that plus and minus degree, and that will highlight polygons that are facing downward by the indicated angle. And that'll kind of help you isolate where you can put your supports. Now what's kind of cool here is, under the view options, if you go to the 50% transparent, on the right-hand side of the screen underneath rotate there, yeah. So now it's showing most of the model transparent, but it's showing the downward-facing polygons highlighted in red. That's kind of a cool effect. It's very Christmassy. It's all red and green.
It totally is. And then I've noticed sometimes, in order, especially with this aluminum build tray, sometimes what you want to do is give your model some surface area that it can actually, those first few layers can bond really well to the build tray. So here it just finished building these, they look like bed of nails, but it's not bed of nails, it's a different algorithm.
That's correct. It's gone through the model and it's tried to identify unsupported regions in the model, or if not unsupported, a minimum gap of 4 millimeters. So it's kind of walked all through the object to see best placements. And
wow.
It does a decent job. I'm still working on it a little bit, but it definitely allows you to take out some of the guesswork.
Yeah, and Brad, you might know, have some insight. Are there parameters that you prefer in your support generation?
You know, it's tough to say. I have to say, I generally do a lot of manual support generation myself. So I haven't played too much with the automatic generation that Steve's been working on. Partly because it's been getting a lot better. Originally, I don't think he had the adaptive options in there, and I just haven't had as much time lately. But so I've been using, I'd say for most of my prints, at least up until now, I've been doing manual generation either with a Mesh Mixer or with B9's layout software. But definitely as Creation Workshop, you know, it looks like it's a lot more full-featured than when we were first using it, and you could definitely see it being a complete solution, you know, pretty soon, or if not now. I mean, I haven't. I've used some of the latest versions, but mainly just checking for functionality and things like that, as opposed to
Compatibility.
exactly.
And as far as support shape, I noticed there's also an option over here on the left-hand side, support shape, and those are usually that was already all filled in for us. Is
Right.
that something that we need to? Is that something that you change a lot, or is that something?
Well, I found a couple of good shapes that work here. So it's referring to the diameters, not the radius, in there. So 200 micron tip, and then 500 micron sort of tube that goes down to a 2 millimeter base area. Oh, I do want to show you a neat trick. So if you actually double click on one of those supports, one of the yellow supports, I could show you something neat you can do with it. All right, so now you've got a support, and if you move your mouse cursor, actually, hold on, get more of a top-down view here for a second. All right, so now we've got one of these supports, actually more of a side kind of top-down, three-quarter view. All right, so now you can hold down the Shift key and move your mouse around on, where'd it go? There.
Shift.
All right, hold
it
down and move around your mouse, and it will actually slide around that support and automatically intersect with the object above it. Since this is kind of a complex model, the frame rate's not great.
Yeah,
another trick you can kind of do is hold down the Control key and then click somewhere on the model.
Oh, wow. I had no idea it did this.
And now you've kind of got an angled support that can kind of angle into those hard-to-reach areas. I see you've got it right there in his crotch.
Hey, that hurts.
All right. But yeah, you can put it on his elbow or the tip of his nose, or it definitely helps to try to get into some areas without kind of intersecting the geometry of the model below it. It doesn't work in all cases. What I really need to do is make sure I kind of go around the edge of the object. But it's getting better.
Yeah, and so so we're not quite there yet, right? So this is like preparing the model for print, but we also need to configure what's called a slice profile, right? And that varies from material to material, because some materials you're going to need to expose longer and kind of handle them a little bit different in the actual. It's similar to having a different extrusion temperature for FFF. In some plastics need to be hotter than others relative to others. It's the same thing with these photopolymers. Some of these photopolymers need to be exposed for a longer period of time. So we need to set that up, right?
That's correct. So if you click on the Configure tab there at the top, we can take a look at Configure Slicing Profile.
Okay, cool.
All right, so let's set up a new slicing profile here. We'll say Create.
And let's call this Maker Juice.
Well, hold on. Actually, let's call it LittleRP 100, and I'll tell you why here in a minute.
Okay, I'm glad we have the expert.
All right, so LittleRP 100. Let's click on that, and then also select it from the profile in use on the top there. All right, so we're going to configure this for 100 micron slice thickness. So under exposure settings, making some notes, that's what I put it there for. All right. So we can actually have multiple resin profiles for this single slicing profile. So if you've got 4 or 5 different resins that you'd like to try out, we can create new resin profiles in here, and each resin profile can have some different variations on exposure time. So I see you're setting it up for Maker Juice SF Red. That sounds good. All right, so under slice thickness, let's set it to 100 microns, or 1/10 of a millimeter.
So, so 0.1 millimeters is 100 microns, and 0.05 is 50 microns, right?
That's correct.
So it's probably best. You probably would say it's probably best to tinker with the coarser of the two first. That's what I found. And even at 100 microns, it's incredible, the detail. I mean, I have this little Yoda Buddha here, and I printed him at 100 microns, and he looks amazing. The detail is unbelievable on him. So, okay, and then we're down. The next menu item is exposure time.
Yeah, so the exposure time basically denotes how long the current image slice should be shown through the projector onto the slice of resin that we're exposing. So I'm not sure about how long the Makerjuice SF Red recommended times would say. Do you guys have a clue on these?
Well, so there's a couple things too. I don't know if some individuals have already purchased some of this LittleRP Makerjuice SF. You might want to email Makerjuice and ask them which batch you got, because some of the initial batch that they sent had the standard. So what makes this LittleRP specific is Makerjuice has their SF resin, which is snap fit. So they have a couple of different resins, and one of them is they originally started their G, sub G, and then they had sub G plus, and then they went with a snap fit. And the primary reason we use snap fit is that it can hold enough pigment to do small details. The problem you have with sub G and sub G plus is it's a thinner resin, so it doesn't. Makerjuice uses a pigment. It's kind of almost like I don't know, like a printing press style pigment. You know, it's a particulate, so it will settle out of a resin, and that's why Makerjuice you have to shake before each use, whereas say with Made Solid you don't, because they use more of a dye that won't settle out. So the way the pigmentation on Makerjuice works is he has a certain amount of pigment that for each color that goes in a certain volume of resin, and for sub G it's like 1 strength, G plus is 2 strength, and sub SF is basically 4 strength. And the main difference with the LittleRP resin is this is essentially like 8 times the strength of sub G, so it's basically has twice the pigmentation of the standard sub SF. So if you bought regular sub SF off of Makerjuice's website, it wouldn't have as much pigmentation as I prefer. So one nice thing about Makerjuice as well is that you can purchase the pigmentation on its own. So you can talk to them, get he'll sell you like a dropper of extra pigment, so you can sort of get it up to this. What you want is double strength of standard sub SF. But some of the bottles that he did sell originally only had basically 1 times the strength. Another thing we also did too is in order, because the LittleRP is sort of, it's kind of, since you're focusing all that projection onto such a small area, you know, it's if you're having the X and Y projection size, you're basically quadrupling the amount of UV that's being focused on that area. So we actually run into the area, so you'll notice with some of the projectors or do-it-yourself SLA projectors, when you're doing a large area, sometimes they'll remove a UV filter, they'll remove the color wheel and a DLP. In our case, we have way more UV than we really need, so we don't do that. And this is sort of another case where we're trying to mitigate. So we're trying to. It's an exothermic reaction when you cure it. So, and PDMS coating is kind of delicate, so it will break down with heat. So what we're trying to do is limit the heat buildup, and one way of doing that is by basically reducing the amount of photoinitiator in a resin. And photoinitiator is that's what reacts with the ultraviolet light. It breaks apart and it polymerizes the monomers that are in here. So if you If you reduce, so that's kind of the two ways you can play with a resin. Is you can increase and decrease the amount of photo initiator, or you can increase and decrease the amount of pigmentation or UV blocker. So what Josh at MakerJuice has done for us is we've doubled the pigment on the sub SF stuff, and we've also dropped the pigmentation, I mean the photo initiator, I believe by half. And so what that does is it will increase your cure time. So whereas the standard high photo initiator concentration, we were looking at like maybe a 1500 millisecond layer time.
So 1.5 seconds.
1.5 seconds.
Per layer.
Per layer. And with the low PI, it's probably somewhere around 2500. So.
And I've been using, I've found it oftentimes makes more sense to weigh on the more time.
Yeah, so there's a couple of things. One of the things that you'll do when you first have your printer is, this is the same for probably any printer. Granted, I will have sort of specific times that I know work with this resin or the made solid resin that we provide, but projector bulbs will age depending on the distance of your projector. That increases or decreases the intensity of the UV over a similar sized area. So your cure time will vary. So it's still good to know how to figure out what the appropriate cure time is for your printer. And there are a couple ways of doing that. We have a calibration piece. It's a small print. It's short, which is nice because the SLA printers are a little bit slower than some of the FDM printers. So you don't necessarily want to do a gigantic print and then go, okay,
right,
well, I need to dial it down or bring it up. But one of the downsides of going too low on your cure time initially is that if your model doesn't fully form, then you sort of end up with partially cured debris in your vat. And what that will do is the next time you try and print, when you lower the build plate, the debris sort of trapped below it, so you don't get a good first layer. So it is a good idea to maybe shoot a little high than a little bit too low, just so you don't have to deal with that issue. And the downside of shooting too high is that PDMS really does not like it when the print is overcured. So we're trying to ride this fine line of we want the cure time to be just long enough so that the model is fully and appropriately formed. But there is definitely a downside to, let's triple that. Some of the resins will react differently to that. Some of the, like MakerJuice, the model will it'll inflate. Some of the features will expand. You'll lose some of the dimensional accuracy, whereas the made solid resin doesn't typically do that. So.
Now, is Made Solid making specifically for the LittleRP now?
So what happened with Made Solid originally is they had their V1 series resins, and they originally produced those for Made Solid. Their primary target, at least historically, has been to sell resin for Form 1 users, and it just happened that their resin worked really well on these DLP projector printers like I have with LittleRP. And so originally they had black, blue, white, red, and the black and red worked really well. The black was sort of damaging to the PDMS. The red really didn't have that issue, but the black was kind of bad. So Made Solid sort of had this reputation originally for it being a lot harder on the Form 1's PDMS than the Form 1 resin.
I can attest to that.
So what they've done is they've reformulated their resin, and so now they have a new V2 resin, and they look quite a bit different. It's a lot more transparent. The colors aren't necessarily as vibrant. And there is a difference in choosing an appropriate resin when dealing with a DLP printer and a laser galvo SLA printer. And I think a lot of that has to do with the lasers are very narrow frequency that they use when curing the resin, and additionally they're only curing a single spot at a time. I think with the DLPs, a lot of the problems that you'll run into are, since we're illuminating the entire layer at the time, we sort of have more issues with light penetration and things like that. So a resin that might work well on the Form 1 doesn't necessarily mean it's going to work well for DLP printing. And as with a DLP-based SLA printer, as the build size gets larger and the cure time goes up considerably, because you can imagine if you doubled the build size of a LittleRP but use the same projector,
you're getting half the UV.
Well, you're getting a quarter of the UV.
Oh.
So at least over the similar size area. Well, I mean, if you double the X and Y,
got it.
You get 4 times that. So once you start getting larger than that, then the differences sort of go away. But at least for what we're doing, which is sort of high quality, smaller build size, you do sort of have to get resins that are sort of tailored for this. And you'll notice that with B9's resins too. I think their B9 cherry resin is 9% pigment, so that's something you would never really need on a Form 1. I will say, for the people who are curious, I have tried Form 1 resin. It's not satisfactory. It's extremely slow curing on a machine like this, and it just doesn't have the blocker we need in it, and it has a different base to it than the Made Salt and Maker Juice resins that we have. So
that's good to know.
Yeah, it's probably more than you want to know about that.
So, Steve, where do we want to go now? Because you mentioned you're kind of pressed on time. So, do you want to do a little bit more with?
Well, I think we should finish our slice profile if we can. If Steve has a minute.
Yeah, sure.
And so I think our exposure time.
I would say probably about 3,000.
3,000
milliseconds.
When I first started, because I was having a hard time getting my builds to adhere to the plate, especially the first few layers, I actually jacked this up, this value here, to 7,500, and I jacked this value all the way up to 5,000, and I saw no negative.
I mean, it depends too. Some of your resins will also behave differently. They sort of have different personalities, and Maker Juice, as the model gets larger, will typically require a longer exposure time, and it's a little counterintuitive, because you think the cure time should be the same on each segment, but for whatever reason, I think it's because we're generally under curing the Maker Juice resin, whereas the Made Solid, if you're printing something very small or very large, that doesn't happen. You sort of end up with the same size. So it may be depending on what size model you're printing.
So 3,500, and you would recommend maybe a 5,000 to get started.
I generally double it.
Okay.
And if you even have a problem with that, then overcuring is okay for a few layers. It's just you don't want to consistently overcure.
Maybe do the first 5 layers or something.
Yeah, I generally do. I would do 5 bottom layers for 100 micron, and then I would go to maybe 10 for if I was doing 50 micron.
And then there's this option to enable anti-aliasing. I know I'm supposed to check that, but what is that?
I think I could talk about this. All right, so let me see the screen, actually. I'm just looking at you guys right now.
Yeah.
Yeah. All right, there we go. So anti-aliasing. So what this does is I've got this anti-aliasing checkbox and a little number by it. So right now, I think the projector is, 1024 by 768?
I think the one that Mike's using is a 1080p.
Oh, okay. So basically, this is just an XY scaling factor. So instead of 1024 by 768 or 1080, it'll be that times 1.5. So it'll render the image at a higher resolution and then scale it back down, back to the original resolution. Well, why do you want to do that? There was actually a long debate inside the Build Your Own SLA forum as to how we should treat the edges of models. And I think on some of the B9 creator forums there was also a debate as far as can you have partially cured edge pixels or not. So there was actually a few users on the Build Your Own SLA forum who went through and they tried a variety of anti-aliasing factors. And I think they came up with the value of 3.5 that worked the best. They did the same print with, the same model with several different anti-aliasing factors and then compared them all side by side to sort of show the smoothness of the edge. And in a lot of ways, this actually kind of replicates a patented technology of pixel shifting.
That's interesting. So I guess even I learned something. I always thought that the anti-aliasing is sort of a pixel length to blur, sort of like in Photoshop, but I didn't know it was scaling and then resampling.
Well, it's kind
Awesome.
of
So yeah, that's good to know. So we'll set it at so
yeah.
I think I'll go with the Build Your Own SLA forum guys that have done a lot of testing. We'll just put 3.5 there.
How much impact will we notice on slicing time by?
It really depends on the complexity of the model. And
the
there's
processor
things that get into this. So it's also interesting to point out that Creation Workshop can operate in two different kind of modes. You can slice and display at the same time, or you can pre-slice all of your images to a CWS file and then print them later. So,
which is what we're going to do today because we're not actually hooked up to the LittleRP with the projector.
Okay. So just going from top to bottom here, actually, Brad, you might want to help me out a little bit as far as the lift and sequence time. That really depends on the lift distance.
Yeah, so I imagine a lot of this will vary based on the manufacturer. So Steve can correct me if I'm wrong, but like lift and sequence time is basically saying how long does it take for the machine to cycle. It's basically start its peeling of that current layer and then get back and ready for the next layer. And that's I sort of derive that based on trial and error. And a lot of that depends on if you have a controller, those acceleration values that are on it will, it's even if you give it the same G code, different printers with different controllers will do those in different times. So I think that we came up with 3900 for ours.
Yeah, and I will mention while I'm thinking about it too is and while you're testing all these parameters, what it's a really good idea. We're going to go and we're going to slice that model, that ELF model that we had there at the beginning. We're in just a sec when we finish filling this out. But one thing you're really going to want to do is before you get ahead of yourself, just put this away. Put this away and do some blind trial runs without any resin in the printer and make sure that the image is projecting properly, make sure that it's moving the way that it should be, and that you understand the mechanics of the printer before you put the resin in there. Because otherwise you're just going to make a mess and you're going to end up with many failed prints and a lot of wasted resin. So it's probably a good idea to just hook your projector up, make sure it's projecting the image, the right slice onto the build platform, the tilt function is working properly, it lifts, comes back, and the timing is right. You're going to want to go through the process and actually watch the printer and kind of see what its behavior is and make sure that it's doing it correctly before you pour resin into it.
And you want to make sure you take off that cover and put your eye as close as you can to that.
So with each kit I've included a small welding shield. And it's sort of a number 5 welding shield, and whenever you're looking at the projector, since it is, think, oh, it's just a projector, but we're sort of focused, it's just like, oh, it's just the sun, but you use a magnifying glass and you burn ants with it. So make sure you use proper eye protection when looking directly at the projected image.
That Acer there does 3,000 lumens, so that is pretty bright, especially if you concentrate it. So.
And so our Z lift distance is, I'm guessing, how far it's lifting up when it's peeling.
That's correct.
And how fast?
Well, the Z lift distance is how far it's going to lift up, and then
the Z lift speed is how fast. How many millimeters per minute?
Yes, millimeters per minute.
And then retract speed, I don't think that applies to us, or does it?
No, it does, actually. So there's two different things going on. There's the lift that goes up, and then the retract that goes back down. You want the lift speed to probably be about half the retract speed. And that basically helps the current slice peel off the bottom of the PDMS by having a slightly slower speed. But you know, the retract speed, it can be a lot faster because that's just moving straight back down.
Yeah.
And then there's a slide tilt value. What does that tell us?
Okay, so with printers that have a tilt mechanism, like Brad's LittleRP here, that basically will say how many units to tilt the projector and tilt it back, or if it had a slide mechanism, how far to slide it over and slide it back.
So what do we...
I mean, I would say maybe just for the purposes of this podcast that we should just treat the printer as if it didn't have a tilt mechanism, because it's a little bit more to get into. As far as the G code on it's a little strange. So yeah, and I typically use like Steve was saying, I use a lift speed of 100, but a retract speed of 200. And that's because you kind of want to be as gentle. You know, it pays to be gentle when removing the resin, the cured resin from the build plate, but at the same time you can't wait all day. So.
And this image reflection, is that something that we need to worry about or no?
So image reflection, if you're using a mirror, you're probably going to have to reflect either the X or Y. I can't remember how the LittleRP is set up offhand. Brad, do you use the reflect X or Y?
I think they do both, but it doesn't matter. I mean, when you reflect the Y...
Well, if you reflect the X and Y, it's basically just rotating the image 180 degrees.
Right.
Reflecting the X is just going to be... Well, I'm trying to remember if this thing prints backwards or not.
I think I generally just reflect the Y.
Reflect the Y.
But yeah, I don't know how to looking offhand.
Right.
I don't remember. But
and then we have these export options. We have options to export the slices to CWS, a creation workshop software file. Is that what that means?
Yeah, that's correct. So basically, a CWS file is just really a zip file in disguise. And you export slices into the CWS file. It's just going to create a series of PNG files into the CWS file, along with the sliced G-code file, an XML file describing some metadata information, and then it will also contain your original models and supports that you've created for the scene. So then later, you can take this CWS file, just reload it, and then click print.
So we just hit this. So if we were going to export?
I've also got some SVG options in there as well. So I actually had a client, somebody else I was licensing the software to, who wanted to have an SVG export. So this is export SVG only. It actually does not use these SVG generated paths. It creates the generated paths during runtime, so it doesn't really need to reload them from disk. But if you did want to export some of these SVG files to third-party software, you could use Words in them inside some sort of, I don't know, Photoshop or whatever browser.
Got it. And so I think for the sake of this demo, and then basically you don't want to forget to, I've noticed, click on this Apply Changes tab.
Keep applying changes anytime.
It's basically like save. Just click it. If you have info that you want to save, just click it. So when we were in this configure machine dialog, this next tab over, we clicked this manual G code, and so what I've noticed is when you're in this configuring slicing profile, what that does is it basically will allow you to run custom G code at different times of the print, and a lot of times these are either in the forums. You can get the info from the forums. That's where I normally got it, but it looks almost like kind of like our G code.
It is G code. As I mentioned before, we're just using standard Marlin or Sprinter or Gerbil firmwares. So any kind of G code that machine would understand, you can put inside here. I also have a couple quirky things going on if you go to the lift code. So what you're looking at right now in these G code sections is a mix of G code along with some preprocessor G-code slice time commands.
Like variables.
What that means is, you'll see that I've got these $ variables which tie to values directly in the options tab in the GUI. And then I also have some comparison operators in there, as well as multiplication, addition, subtraction, things like that. So you could start to build up interesting commands. So like if you're taking a look at the top line, that basically says $ slide tilt value not equal 0, question mark, use X or use nothing. So what that says is if there is a slide tilt value, if it's not 0, then use that for the X. And then following that, there is Z followed by the lift distance times the lift direction, the Z direction. And then I put in the feed rate variable. So this might not make too much sense right now, but if you actually slice the model and then take a look at the generated G-code, I think you could start to understand exactly how this is translated into the G-code that the machine is going to be operating on.
Well, it's really useful in that it's sort of extensible, and you can sort of modify your G-code to fit sort of a non-standard printer. And it was very useful when I came up with the sort of the tilt upgrade on the LittleRP, and that's because the VAT's a little different on this machine in that we don't really have room to tilt down like most printers will, so we actually tilt up. The downside of you can imagine with tilting up is that you're going to smash into the build plate. So we have to tilt the bed up while we lift the build plate up at the same time, and you only need to do that for a certain amount of the lift cycle. So actually, we'll use things like I lift the build plate and the vat up at the same time, but only for half the lift distance. And then for the next half of the lift distance, the vat goes down and the arm continues to go up. So, and that's really easy to set up, and when you have the sort of the G-code and access to these variables.
Interesting. And so now we come back. We finished that custom G-code, and if you put in your custom G-code for that LittleRP machine, definitely make sure you hit save. And so I think we're pretty much ready to slice.
Well, one thing too for the LittleRP.
Yeah.
I don't quite remember. I believe it's in pre-slice, or is it in lift? Go ahead and I think it's in the lift section. So what I've noticed, and I don't know, maybe Steve can shed some light on this, but I've noticed that we've had to put a manual delay before the lift sequence, basically to give. So it's like it seems like we play with two things. One, we play with the cycle time, but also sometimes adding a delay in the lift sequence before. So we sort of had two problems. One is that the image would project, and then the lift would happen while it was still projecting. And the other issue was that it would start projecting the next image before the arm was down. So it's like to compensate for those two things is one, you can compensate by adjusting the cycle time. The second is by inserting a delay into the lift G-code.
Yeah, I noticed that this number here, the lift and sequence time, if you extend that out, it will get rid of that problem.
Okay. I think too with the tilt, when you're using a tilt sequence, or when you're using the tilt mechanism, the lift and sequence time does go up to 5,500, I think.
So you're introducing more time to the actual sequence itself.
Yeah,
too.
well, because the sequence is longer, so we need to reflect that.
Right. So that's why what I've noticed is if I increase this lift and sequence time, if this sequence time is shorter than this bottom exposure time, you'll start running into that problem as soon as I start running into that problem. Like if this 3900 is shorter than 7000, I still run into the problem. So I think we still have some G-code that we'll probably be working on in the next couple weeks. Maybe Brad and I will work on it.
Yeah, I mean, as far as there is if you download the version of Creation Workshop off the LittleRP website, and there is a video in the technical support section that goes through basic configuration. Those settings will work for your kit. As far as if you want to use tilt, I mean, it's not a kit that's available yet, so we'll definitely have those settings figured out by the time
Right.
those are available.
And I think I had mentioned before, Brad, so if you've got some slice settings or machine configuration profiles for your users, I can definitely include them in the main distribution in future versions.
Okay, sure.
To help kind of simplify this.
Right. Yeah, and so so I think we've got our profile all for this 100mm thickness. So what we want to do is go into 3D, right? Check our model again. Make sure that that's double check that that's what we want to slice, and then there's this button up here, right?
That's the one. Although it's probably going to
like
to save the file first.
Yeah. So exactly. So another good one to do, good practice, is save this.
Don't save it to OneDrive. Oh, right, defaults.
Just save it to.
Yep.
Save the file. I'm just going to save it to the desktop here. And then we click that slice, and under slice profile it says LittleRP 100, and it's going to be using the profile of the resin that we have selected in that slicing profile, correct?
Correct.
Okay, and then we hit slice, and it's going to go through. This little elf is almost 700 layers, so it's going to be about 70 millimeters
So
tall.
why don't we switch back to the main screen, and then we can try and set up this printer while that's slicing.
So one thing I did want to mention here is, exporting slices isn't completely necessary. You can actually print without slicing to a CWS file if you don't have that CWS box checked inside the configure.
So you're.
So if you click on the configure again, if it'll let you. Yeah. So if you're not exporting slices to CWS, if you don't have anything checked inside the export options, then it won't have to go through that whole slicing process. You just click the slice button, you're ready to print. You're ready to print.
We can go right into slice view. And so here we are. Let's bring up our that other this screen, our screen here. And so what you can see here, it just looks like a blob, Steve.
Yeah, it kind of does. So we're looking at the first layer.
That's the first layer?
That's the first layer. So those kind of circular regions in there are the bottom foot of the supports.
So what we're looking at is basically
put it on the 50% view, or the 50% transparent view.
So if you're looking at the view, the sliced view, that's the first layer. And as we come up through the model, that's all 693 layers. So it's basically like an interference pattern, an interference pattern between the X and Y plane, or the Z plane, excuse me, the top plane, and the model. So this is like, it's almost like an MRI. It's looking at an MRI.
That's a good analogy. It's basically taking a thin Z cross-sectional slice of the model at varying heights.
And so I like to go through, and depending on the computer you have, because some computers, my laptop doesn't do a very good job of scrolling through this, but my other workstation is like, I can drag this and it's like fluid.
Just like butter. Actually, if you go to the 3D view, I could show you something cool here.
Okay.
Now make the model 50% transparent under view options there. Now kind of get a front view, and now with the scroll bar down at the bottom, you can kind of intersect the model. Wait, what's going on? Oh, there it goes.
I learn something new every day.
And that will basically show you what you were looking at there inside the slice field.
Oh, that's brilliant. I had no idea it even did that.
You know, I should probably write a better manual.
Well, you know, it's it's a work in progress, and
Yeah, it is what it is.
and we couldn't have done we either way. This just none of this would be possible without you, Steve, and your contribution to this software. It's so user friendly, and did we mention it's 100% free at this point?
It's a bargain at twice the price.
Brad says it's a bargain at twice the price.
Yeah, thanks.
So yeah, no, I really love it, and I should mention too, Steve is real active on GitHub, and he actually has this software is not untitled creation workshop on the GitHub It's actually,
I started this project off and I called it UV-DLP Slicer Controller or something silly like that. And then I was thinking, well, that's not a good name. I should probably call it something better. I don't know. But it's
so
under that name.
Yeah, so if you're a programmer, and how is this program? What did you mostly? You programmed it in C#?
Yeah, that's correct. It runs under C#. It can also work under the Mono framework for Linux. Mac was working at some point. The current version has got a couple issues. I also successfully got it working on an ARM-based platform. There's another wonderful side project kind of put out by Sean O'Brien, who takes the output format of the CWS file and he's got a dedicated embedded Raspberry Pi host. So you can control your Raspberry Pi on, so you'll have a Raspberry Pi inside your printer, and then you can control it via HTML page through a web browser.
You're kidding me.
Over CWS files to it that you slice on your desktop.
Has he already gone live with that project?
I think so. Yeah.
And do you have you used it yourself?
I have compiled the code. I have not actually done any prints with it, but.
And is he on GitHub? Is there a way we could get his name or get the name of that software? Because I know all of us here are pretty anxious to get the LittleRP going, and rather than have to have a dedicated piece of hardware like a dedicated PC, which basically has to have a GPU to have 2 monitors. What I'd love to have is the Raspberry Pi, because it's already got an HDMI out. You can plug it right into your projector.
Yeah.
And you really could control the GUI over the network.
I completely 100% agree. A lot of
$35
for different DLP SLA-based embedded solutions, and this is really the first viable one. There's another project I know about that adds a secondary X-Window display driver to the LittleRP, so you could have an LCD touch controller as well as the video output for the video projector.
Awesome. And so do you know the name of that software?
You know, I'm going to have to send you a link after the show here. The guy's name is Sean O'Brien. Brilliant guy. Good guy.
Awesome.
All right.
Well, we will definitely be looking into that and kind of have it in the show notes coming up, or after the show we'll add them into the liner.
Yeah, and I mean one of the things we wanted to do with Kickstarter was be able to get some individuals, some hardware who could help develop additional Raspberry Pi hosts. And I know I'm working with one individual, friend of mine, who does embedded work, and what I want to develop with him, he has some working source code currently, but it's not something that necessarily is ready for prime time yet. But we do the export.
I remember talking to you about that.
Yeah, and so the idea with that is that we'll do a standalone host with what we're using it right now is a Raspberry Pi and an Adafruit LED button shield, and the idea is that we'll be able to go to Creation Workshop, export your slices to a USB drive, plug that in the Pi, and select that from the LCD, and initiate your print that way. So, and I know of another individual, Bob Clow, in the UK, He has a Python-based host for Raspberry Pi that he's working on also. So there should be a number of options, hopefully.
Yeah, it's up and coming.
Awesome.
But for now,
So where are we at, Brad?
gone
As far
ahead.
as
Oh, sorry.
Go ahead, Steve. Sorry.
Well, I was just about to say what you've been doing, Michael. As far as a few of us have actually taken Windows 8 tablets and have been using those as sort of embedded controllers for machines like the for machines like the LittleRP here.
Yeah, and actually, even though this particular version of Windows 8 doesn't supply it, you have to get the Pro version. You can get a third-party source that allows you to remote control it. I don't know why they didn't include it in all the versions of Windows 8 RDP, but that would allow you to remotely control it from anywhere. But like I said, there are third-party sources for that capability. And the nice thing, and thank you, Steve, on this particular, and I did mention it in last week's 3D in Review, this WinBook, here, thank you, Brad. This WinBook here, what is it called, the 801 or something like that? It was on sale
TW801.
Was it Micro Center for $139? And the important thing is, if you show the ports, it has a full-size USB as well as a charging micro USB port. So now you are able to keep it charged while you're using it, unlike the Acer we had before. So again, thanks, Steve, for able to go out to Micro Center and pick that up for me. And
You're quite welcome.
I won't be doing it today, but I will be trying it in the week over holidays. I guess I'll find some time to actually print. Now that I got you all together, if I don't have this thing up and running by next week, you can come by and personally shoot me. And in fact, I think my wife, Siobhan, will give you the gun. So please, Brad, kind of identify. Chris did a good job earlier of talking about the different components, but what you've done while Steve was talking is hooked up the Acer projector. Now, what makes this projector different than the one that you were selling in some of your kits is that this is the 1080p version. And we were able to just hook it right up and not have to modify anything. Is that correct?
Yeah, so originally when I made the kit, the idea was that you could use inexpensive DLP projectors, maybe if you purchase this off eBay, or like originally the first projector I used was just a Dell 2300MP, I think it was, and I bought it for $100 used off eBay. And when you're doing something at such a small build area, 1024 by 768 is actually pretty adequate. That'll get you down to almost 50 microns, which is pretty, that's, depending on what you're doing, it's quite good. I guess you could say.
Yeah, we got some samples here, and you probably can't see them from that camera there, but yes, we showed them earlier, and they are extremely good.
And I run the non-HD version of it because the projector is about half the price.
Yeah, so the downside with the 1024 projectors is that, like most projectors you'll try and use, they do require some modification to allow the extremely close focus. It just happens that being able to focus at 90 millimeters is not something that projector manufacturers advertise in their manuals, because it's not a use case scenario that people are looking for. So most don't, some do. The only way to sort of tell that is trial and error, right? So you buy one, test one. But it just turns out that the Acer, the 1080p series of projectors, the H6510BD and the P1500, which are basically the same printer, except that one's a little more stripped down on the electronics, port options, things like that, than the other. But they happen to be able to focus right at that almost 90 millimeter range. So
without even having to modify.
Without having to modify it. So
that might be worth. For those people that are looking for just an out-of-the-box solution.
Yeah, I mean.
Yeah. Plus, this 1080p I was able to pick on eBay for $500.
Yeah, so this is you'll find it new, generally on sale for about $600, whereas the 1024 projector that we recommend is you can find it for about $300 on sale. You will note, I don't know that you can really tell here, but this projector is actually situated closer in, to the printer than the 1024, and you'll notice that if you look at the mounting feet or the mounting holes for the projector on the bottom, I can't really see that well because it's black, but there's a set of holes that are closer in, and on the shipping version of the LittleRP, there's actually, instead of that forward and rear position for these style projectors, there's actually 4 holes now, and the projector standoffs, instead of a single piece, are actually it's a printed piece, and then there's 3 acrylic pieces, so that as you move the projector back 1 hole, you sort of need to drop its height too. So the idea is, if you have it in the forwardmost position, you'll use 3 of those spacers for each mounting leg, and if you use the rearmost position, you don't have to use any of the acrylic spacers. So the 1080p projector people wanted, because they go, oh well, it's kind of like the camera, like megapixel race. I don't really necessarily think it's a requirement for this printer. I think it prints great with the 1024 projector. I also think that the 1024 projector with the modified close focus have a sharper, crisper image. The 1080p projectors can be a little bit soft in the corners, and that's sort of why we've allowed the flexible mounting position for them. So if you think it's too soft, you can pull it back a spacing, drop it down at the sort of the expense of a little bit of the resolution, and your projected image size gets a little bit larger. So, but
So on that
it's super useful because you don't have to modify it. So people are either interested in it because they want more megapixel, or they want more pixels, or just because they won't have to modify it.
Yeah, well, that's a good point, not to modify. But even though it's almost twice the pixels, that doesn't really correlate to precision or not the accuracy, the resolution. You don't get 25 microns from going to 1080p, right?
Yeah. So the way this is done is, well, yeah, because it's 1080p, but it's also the way the image is projected, it's a wider.
16 by 9.
It's 16 by 9, and it's also a wider projected image. So you go from a 40 by 60 projected image on the 1024s to, even though you're closer, you're still going to a 72 wide. So you're still distributing those pixels across a wider distance. So even though you're closer, it's actually the 1024 is about 55 micron XY resolution, and the 1080p, it's not 22.5, it's about 37. So it's not a huge jump. If you do end up with the tilt kit, you're going to probably end up with more build volume, which probably might interest people more.
Well, another thing too, this was a good excuse to get a 1080p for other things like presentations.
Well, the nice thing too, since you don't have to, the ones that you modify, they're sort of locked into that. Like once you modify a projector for close focus, you're not going to be able to focus it at 30 feet and watch movies on it anymore. Whereas with these Acers that we have now, you could unscrew it from the base and watch movies with it, and if you're only going to print a few times a month, you just attach it for when you're going to use it. So it's definitely multi-purpose for that.
I'm behind you, Brad. Just look over your shoulder. No, over your shoulder.
Are you there?
No, down. A little. There I am. I'm a little green today. Thanks. I think I can see you now. That's typical.
All right. But yeah, so the Acers are nice projectors. A lot of people ask me, they go, will this projector work? Will this projector work? Especially a lot of the overseas customers. They may not. A lot of times Acer will change the model number. Instead of like 1283, it's like 1273 or something. And I don't really have a good way of testing those. So a lot of people ask me, will this work? And I can just sort of give them my best guess, but
okay, so now that we have it physically put together, what do we need to do? What do we need to do now? So I'm thinking, if we don't need to look at the software anymore, you can remove the connection to the streaming broadcast system and plug it in the back. Can we move forward with that, or will it blow up?
Well, we're going to we will we're going to have to. Is the software up on there?
I mean, you can probably mirror it, right? Or no, it's only a single connection,
It
right?
has two video connections, so we wouldn't be able to see the software, but we don't really need to see it at this point because we're doing a lot of physical action. Yes? No?
Right.
Okay. So just remove it, because we're not even looking at it now. So just remove the white cable.
So one thing too, when you're going to use, I think any projectors with a creation workshop, it is possible, technically possible, to only have a single monitor output. Run it off a desktop or something like that. It's really, you're going to sort of hate life if you do that, though. As far as the long term, the issue with that being when you initiate the print, at least the LittleRP has a manual shutter, so we basically leave this in until we're ready to start printing, and it would be difficult to find the play button and click on it and have it start projecting if you couldn't. So it's like once you start moving your mouse, or like what if it was projecting the Creation Workshop screen on your projector, like it's going to start curing the resin in those areas. So it's definitely much advisable to run it off a laptop, maybe that will do dual, that has a secondary monitor support.
Brad, I never took the seal off the mirror.
That will make it difficult.
This is where those tweezers would come in handy, right?
Well, it's in there so much. I don't know that you could. Let's go ahead and I'll just.
Yeah, you might be able to take the vat out and get at it from the top there.
Well, since he has the tilt bed, there's an extra. I could probably.
Oh yeah, I know what you're talking about.
He sort of has the deluxe model that I. And he has the old tilt plate that doesn't have the slot cut out for the.
So what are you taking apart right now, Brad?
Well, so right now is this is a piece that does not come with the Kickstarter kit. So the tilt kit has this extra tilting bed. It has this piece of it's a 1/4-inch acrylic, and that's what tilts, and the build vat basically gets clamped onto that. Whereas the non-tilting version, you just have the vat. You don't have this extra piece. So
is there any refraction issues using an acrylic plate?
Since the angle of incidence is pretty
minimal,
it's pretty much dead on. I haven't really noticed anything.
Tweezers.
Yeah, we need some tweezers or something, or a knife, or
that's that spatula.
that may work. So I don't know if you can see on here. You can see actually there's this hole in the back of the where this lead screw kind of protrudes down in a little bit. This is sort of an early version of the tilt, and so what I've done is I've slotted this back out so you could just remove the whole tilting mechanism out this way. Whereas right now it's sort of trapped by the lead screw. But we'll go ahead. Actually, I may not need that. Yeah, go ahead and hold that up. This is an interesting bit of history. This is actually probably the, I don't know, 4th or 5th LittleRP. And I don't know, when did
It's been waiting for you, bro.
When did you have it? You got it like months?
August.
Like August, yeah. Everybody's like, where's my LittleRP? And you just have one you're not even using. So you can kind of see the ideas that.
Is there a little jab there, Brad?
No, there's some rubber spacers under the bottom that elevate this. So actually, it's not flush with this black plate here. And what happens is that gives you enough of a wiggle room for this to lift. So actually, when it tilts, it doesn't actually tilt more than that. It doesn't really need to tilt very much. So we'll go ahead and put these. And the springs are what keep it. It's a very simple tilt mechanism. What keeps this, when it's done tilting, what returns it to its stock position are these springs that are on the existing. We reuse the existing posts that you would use for a Petri hold down.
What kind of printer were you using when you printed these?
So these are printed with a Maker's Toolworks Fusematic. which is a printer I like because it's kind of inexpensive, and I definitely recommend it to people. It's not much more than like an i3 kit would cost you, but you end up with sort of a much higher quality printer. It's the same company that does Middlemax 2, and Middlemax 2 wasn't my favorite. I never had one, but they've just come out with a Middlemax 3, and I was part of the beta test for that, and I really like that. You'll notice that the parts that come with your kit, I did have a colleague of mine print them for me, and he printed them on Middlemax 2 or Middlemax 3, and they're pretty good quality. We were trying to print the parts fairly rapidly, so keep that in mind when you see them. We did use a coarser layer height. We print them at 0.3 layer height instead of 0.2, and it's a little bit faster than we normally would use, but definitely excellent printers. Okay, so we have the sort of he brings up an important point. When I ship the mirrors with your kit, they have this blue film on them, and that's basically just a protective film. The type of mirror that we use is it's a first surface mirror, and what that means is that the mirrored surface is on the front. Most mirrors, like in your house, will have the mirrored surface on the back side of the glass, and that's mainly for durability reasons. Well, it's for a couple of reasons. You don't actually have to polish a mirror that way necessarily. It's it's like the back of a mirror isn't necessarily shiny also, so there's some production reasons. But so the mirror that is sent with the LittleRP it's a special type of mirror. It's not super exotic, but what we actually use is kaleidoscope mirrors, and they're first surface mirrors also. But what it does is it prevents, you can imagine if the mirror's at an angle and the projection is hitting that mirror and then being directed up.
Just go through the glass twice.
If it could go through the glass, then you're going to end up with sort of a ghosting image. You're going to end up with like a double image. So it's not good for our application. So that's why we use the first surface mirror. But to protect it, we ship it with the blue little sticker on it.
It's maybe a little bit more delicate.
Yeah, definitely. You could scratch it because like a regular mirror, it's just a glass on the front.
You can polish the glass and it's brand new.
Well, and glass is a lot more scratch resistant than what this essentially is like I'm assuming it's like gas. No, it's aluminum, but I think it's probably gas deposited or something. So it's like very very thin. Yeah. So and keep that in mind when you're cleaning your lens or you're cleaning your mirror too. Use like a lint-free like eyeglass wipe or something like that. Don't scrub it because
don't take your SOS to it.
Could damage the aluminum.
Don't use Brillo pad.
Good thinking.
So you'll notice we have this projector hooked up and running now. It's turned on. It's running. Its HDMI is in on it. One of the things with the LittleRP is Gerbil doesn't really have a motor hold function, so we can actually just move the Z on our own, and that's sort of useful. So to raise it up and down, we actually you can do it. You can either do it with the jog controls in Creation Workshop, or what I tend to do, it's way easier, is I will just lift the arm up and down. You can see that it's stiff enough that it's not going to move on its own, and you can also turn the lead screw by hand too if you want to get.
I like that method because your hands get really greasy and it takes a lot longer.
What would be useful maybe is to have but if you need precision, it's going to be easier to do it that way. And maybe you might you'd print like a little knob with a set screw on or something.
What I like to do is I like to raise it
That's
up.
what I have with
and then I put when I have my build tray in there and I put the sauce in there, what I do is I dip it in the sauce once, pull it out just a second, put it all the way bottomed out, but that's not actually bottomed out.
Strawberry or blueberry sauce.
And then just tighten it up by doing you can feel it do 3 more clicks if you turn it counterclockwise, and then that's actually bottomed out.
Yeah, I mean, well, it depends on the type of dish you're using. If you're using one of the dishes that we include are these sort of thicker acrylic dishes, and the bottoms don't generally bow on them very much. If you're using the Nalgene that we recommend, like Nalgene 5500. They're PMP dishes. They're fairly thin, so actually, if you do press down on the Z arm, you can bow at the bottom. So it's useful if you push it down, you might back off the build plate a little bit manually to sort of take that bow out. And that's useful. You can imagine that if you're pushing the build plate down and it's bowing the bottom of the dish, you sort of have an inconsistent layer thickness of resin. So you might end up with adherence problems in the middle of your print. If you use our thicker dishes, that's not really an issue you'll run into. But
Now, speaking of, you've just come out with a brand new dish. Is that correct, Dad?
yeah, so the dish is there's a couple different things. The dish is kind of a specialized piece. For the tilt, I mean, the idea with this originally was to use Petri dishes, and you can use polystyrene dishes. The resin will eat polystyrene. My understanding is that it will just sort of fog the edges that aren't coated with a PDMS. If you left it in there for a long duration of time, it might compromise the integrity of it. So it's not really, like, I think the droplet, they just have people use polystyrene dishes. It's not really something I'm interested in doing, even though they're super cheap. But so the only real option I had was the Nalgene PMP dishes, it's an autoclavable Petri dish, and it's made out of a different material than polystyrene. It's made of PMP, which is like, I don't know, polymethyl something. But those work well. The problem with that is that they're pretty expensive. They're probably $7 to $10 a dish, depending on where you buy them. And because the bottom has an injection mark on it, we can only reuse the top dishes, and they're pretty shallow. I think they're in between 12 to 15 millimeters or something like that. So they actually work fine if you don't need to tilt. But you can imagine if your bed's tilting, a shallow dish is not ideal. So we came up with an acrylic dish that is not only thicker, so you don't end up with, so it's just a stronger dish overall, but it is a thicker dish, so that we can use it. We put more resin in it. We can tilt it, not worry about it so much. And so there's been a couple iterations of that. And originally, I did them by hand. I ordered the cylinder offcuts from a company, and I assembled them myself. It's pretty tedious. It's not something I like to do with my day. And that's not me being, I don't have any ego. It's just it's not great, and the chemicals aren't fantastic either. So I contracted out to a couple companies to make a dish for me, and one of them has made a very similar two-piece dish to what you see here. The two-piece dishes are probably they're a little better optically because they're using a flat sheet of cast acrylic as the bottom. The downside with them is they're a little more labor intensive to produce. They're more expensive to obtain. So we also played with, and I didn't know if I could get them in enough quantity before the Kickstarter started shipping. So I actually ended up going. We went a thermoform route, which is it takes a sheet of acrylic and vacuum forms it over a mold, and so that's what's shipping. It's shipping with the kits. At this point, since we've gotten both Petris in, the free included Petri is going to be one of the two-part Petris, and then if you ordered extra dishes, there'll be the thermoform single piece. And so you kind of have a choice. You've got the potentially you might even have three options. One is a cast tube with a cast bottom, an extruded tube with a cast bottom, and the thermoform single piece. The thermoform is nice in some regards too because it doesn't have a glued seam, so it's sort of a safer dish to use.
Does it last longer?
Probably not. I mean, they're probably all about the same. They are acrylic, so they will scratch. So it is useful. I tell people to buy there's like a Novus 3-part polish, and you can get scratches out of acrylic real easy that way.
So if I needed to buy another one, how much would they cost?
So it depends. At the Kickstarter, we were doing $850 per thermoform pre-coated. imagine to be able to buy them coated and
Cheaper than
uncoated.
the Form 1 at $60.
Yeah, I mean, the idea with the LittleRP is that you want to make the vat easily removable, right? So you can say, I want to print with different resins, or I want to tweak with my own formulations, my own colors. So it's nice to be able to just like, I'm going to take the vat out, put a new vat in, and start going, as opposed to, you know, I have this large, you know, I sort of have a large vat, and you know, it may or may not be easy to remove. So I definitely recommend, also too, when you're printing at these really small build areas, we're a little bit tougher on the PDMS than some of the larger SLA printers, and the downside of that is that you will end up wearing out the surface. It depends on what you're printing. You know, maybe every dozen prints, so you'll need to replace the coating. So you need to be able to replace them easier and sort of faster than some of the other printers. And
for $850, I mean, my my build trays that I have to replace that I get from Stratasys is my FDM printer they're like over $5 a piece, and I have to replace them every print. So at $850 and being able to get, maybe you might be able to get 50 prints out of one Petri.
I think it depends on what you're doing. You know, if it's a big print, you might get a couple, right? You know, if it's a big giant block, like
Right.
you're going to start damaging the PDMS. But you know, like Chris said too, we're not like the LittleRP is not about locking people into things. It's not about locking people into our vats. It's using a standard 4-inch vat size. Chris found a Corning dish. That's a glass dish. It has a nice smooth bottom. You can use those. I think they're about $5 a piece, and that's
They're not super optically clear, but they're clear enough that once you coat them, they seem to work. I mean, I've had some successful prints on them. Yeah, well, since then I've moved, and there's documentation again in Steve's forum and Brad's forum. If you go into the Creation Workshop forum at buildyourownSLA.com, there's some great references on kind of who you can get your the PDMS coating. I get mine from a company called ML Solar, and it's basically the same stuff. It's a silicone type coating that they use on solar panels. So it's UV clear, because that's one of the things that one of the unique properties is that obviously it has to be able to be penetrated by UV so that it can expose the photopolymer, but it also has to have silicone-like properties to it so it can release.
well, it needs to be nonstick.
It needs to be nonstick, and it's amazing. If you even pour like alcohol to clean the PDMS, it like pools up.
It'll just I mean, a lot of times when you're done with the resin, you can sort of pour it out of your Petri, and it'll just
all get out of there.
It'll all get out of there, which is kind of interesting.
So can we get on to calibration? We're almost running on 5 o'clock, and so it's kind of running long, but obviously we've got a ton to talk about. So
well, honestly, I wanted to interject here. I actually have to get going, guys. I'm sorry I'm not going to be able to stick around for too much longer, but
hey,
no, that's fine. You hung on there longer than I thought you would, Steve. So
right.
I appreciate you. So did you print anything while we were doing this, or was it just hanging tight?
Who, me? I was just kind of hanging tight.
Okay.
Thanks so much, Steve, and happy holidays to you.
Holidays.
And thanks for joining us.
Happy holidays. Always a pleasure to be
on.
Yeah.
Thanks for being one of Santa's 3D helpers.
All right. Take care, everyone. I'll see you later.
Happy holidays.
Happy holidays.
Yeah, there's a lot to go on. I mean, I think, too, one of the things I'm going to be doing with the technical support section of LittleRP is adding a lot of different video guides as far as calibration. Like, there's a number of calibration pieces. I have one that I use that is really good for dialing in your cure time and your base time.
Right.
And I have another piece, too, where a lot of people, when they first start printing with their LittleRP, they'll say, my prints are like, they're stretched, like they're too tall, or they're you know, like the Z's off, like it's either too tall or too small. And it's actually not the Z, because the Z is actually it's really mechanically coupled, and it's really hard to be off on the Z axis. What it is that your defined build area size in Creation Workshop doesn't exactly match the way your projector is mounted or the setup or the build plate and things like that. So by adjusting what you set as the X and Y in Creation Workshop is how you scale your printed image in the X and Y. And so you basically need to scale it to match what your Z height is. And so I have another STL that's it's 6 posts, and when you print them, you measure across the width, and that should be 50 millimeters, and you measure across the height, and that should be 30. And so if it's off, say it's like 30.5, then you know what percentage to scale down the your
X or Y dimension.
your defined build area size in Creation Workshop software. So.
Oh, okay. So that is a preset that you can configure. I thought you might have to do it model by model.
No. So in Creation Workshop, there is a when you configure, I think it's under the configure tab. You basically tell it a little bit about your machine. So you say on that build size, you tell it how tall your Z is, how wide your X and Y are, and the Creation Workshop doesn't know how big the projected image is on your projector. So you're sort of telling it how big it is. So if you tell it that it's bigger than it is, it's not going to be accurate.
Oh, this is a new model, or this is a new window I haven't seen.
Yeah, I haven't played with that either myself. It looks like that's sort of the same thing that we're talking about. It looks
Keep in
like
mind that we can't see the screen.
Yeah. Well, what we're looking at is there is a little adjustment tab under the build size that you can adjust. You can take a model size and then a measured size, so that you can kind of calibrate. It'll automatically scale your model accordingly.
Yeah, so
you can get more dimensional accuracy.
it just pops up a window and it's saying, it asks you what the model size is, and in this case, since we're measuring across the post, let's just say you had like a 20 millimeter calibration cube, which is what people are sort of familiar with in the RepRap world. You would say, well, the model size is 20 by 20, and then I would measure it and say, it's actually 21 by 21, so I need to scale it. Typically on a RepRap printer, what you would do is you adjust your steps per millimeter, but we don't really have that analog on these resin printers. So what we do is we adjust the build size, and you can sort of think of the X and Y build size as steps per millimeter.
So what physically can you show me without having to go back to the software that needs to be done at this particular point?
So assuming we have our software configured properly, when we have our projector set up, what we'll do is the easiest way is to put your build plate down in position. So you can basically lower it until it's at the top of your vat surface. And then there is a gap through here, and you can look through the gap and you can see, like if you should be using your eye protection, but you can hit the menu button on your projector and you can see the projected image and you can adjust the focus. Typically we want the zoom setting to be all the way unzoomed, so small. So the zoom will enlarge or decrease the projected image size, and so we want it to be as on the smallest possible, and then adjust the focus ring until our image is in focus.
Now there are 2 rings. Which one's the zoom and which one's the...
Typically, it will vary on the projectors. In all the Acers that I've seen, the furthest out ring, like the very end of the projector, is the focus ring, and then the ring that's closer. And so there's I can't really see that real well, but so there's 2 rings. There's one here and there's one here, and this is the focus ring, and this is the zoom ring. So
okay.
So now I have that set up. One thing that's good to do is to in Creation Workshop connect to the So we've connected to the Gerbil shield. One thing that's important to note is that if you do have resin in your tray, to put this basically put this manual shutter in place until you're ready to start printing. Creation Workshop, for whatever reason, sometimes when you hit a tab or hit a button, it'll start flashing a slice of the projected image. So, and the way you can get that off your screen is under the control tab. There's a show blank button on the projector
control. I've noticed that too. So even after it's especially important right after you slice your model. So definitely have this manual shutter put in place. I 3D printed my own, and it looks like the new kits you're going to have. Obviously, it looks like a much more figured out solution. It looks great.
Yeah, the one thing to be aware of is that we are projecting an image in a small area, and that can generate heat. So, you know, if your projector were projecting a solid white image, if it were a printed one of these, it might cause some problems. This is acrylic, which is has a little bit higher melting point, but it's definitely something you want to be aware of. And that's one thing, you know, when using an FDM printer, or I don't FFF, I don't know what the PC term is. It is something that could catch on fire conceivably, and resin printers are no different. So you sort of need to be prepared for an scenario. You have a fire extinguisher.
There's one right outside the
do it in a smart area. So we're gonna go ahead and one thing too.
So you notice if I slice, you notice that there's light coming through there, and that's because Creation Workshop automatically is sending that first slice. So that's why we're saying keep that manual shutter put in place. Go over to your control tab and hit show blank. It'll turn that image off. Then you can pour your resin in, remove that shutter.
Is Steve aware of that? I mean, it seems like
yeah, he has. I think he's been. I've talked to him about it. I think it's something he's working on. Okay. I say leave the shutter in until you're ready. Until you're ready to hit that print button. I mean, this, you know,
it's just good practice.
You could have, you know, there is functionality in Creation Workshop to where you could include some sort of automatic shutter. Since this is sort of like a really like low, you know, inexpensive kit, it's not something that we've implemented, but if it's something, yeah, you could potentially do it where in your G code where the you know, the start section of your G code is to retract that shutter. So
you could use the high IQ version, which says, Chris, remove shutter. Chris, put shutter back in.
I like to also keep it in as best practice because it protects the lens and the focus mechanisms from resin.
Yeah.
So when you're pouring resin into your vat, or when you're putting your vat into here, if you were to inadvertently spill some, before I got into that habit, I leaked a little sauce onto my focus rings, and ever since I've.
I mean, that's one of the downsides of the LittleRP. Definitely is that you sort of have to be careful when installing and removing a build plate or adding more resin. And there's different ways that you can do that more carefully. And one of the things I recommend people do is if they're adding resin to a vat that's already installed, I use 10 millimeter syringes, and you can buy those off Amazon really cheap. And that's what I use to add and remove. I wouldn't ever pour a bottle directly in, just because this is like a recipe for disaster. Like, just you know, get some syringes, some small 10 milliliter syringes. Just be super careful. You could also put something over the top of your projector, as long as you don't block the vents, if you're worried. But that's definitely, and that's sort of a byproduct of we're dealing with such a short focus distance in order to get the resolution that we're desiring. Since the back of the printer has this linear rail and lead screw, if you put the projector in the back, that distance would be too long. So, and it might seem like a no-brainer. Oh, why wouldn't you just put the projector in the back? And in our case, it's not. It's sort of dictated by the physical constraints.
It's still very compact.
So it looks like we're coming up on 5 o'clock.
Yeah. Let me ask one more question to Brad. So if you look behind you in the Form 1, it has a slide-out tray, and people still screw up and pour resin directly in that, and they mess up their mirror. But is there some possibility that you could possibly do that with yours? I mean, I've noticed the clamps that are holding down yours, you don't really aren't calibrating anything with them. They're just for securing it, correct?
Correct.
So you could build a similar mechanism where the tray fits in it and slides out.
Well, so the non-tilt version of the LittleRP actually has Petri hold downs that have grooves in them, and so the dish, you basically loosen it up, you slide the dish in, tighten them,
so it's a lot
undo
easier
it.
to remove it.
Yeah, the tilt is a little bit more awkward.
Okay.
But I'm sure it'll improve over time. That's one of the beauties of open source design. And
one of the beauties of having the designer here in our studio, so we can tell him.
Well, and you have all these SolidWorks files, so anybody that wants to improve upon the design.
I noticed there were a few out there on your website.
So there's some people that might actually work in
Well, yes. I mean, so the source files are up there right now in the sense of DXF and STL. I probably will export to IGS and STEP. Those should be pretty easy for people to work on, even if they're not in SolidWorks. But yeah, so we've got the projector on. We've got Creation Workshop configured. One of the next thing to do is to level the build plate, and that's actually not that complex. What we do is we lower the Z-axis almost all the way down. We loosen the build plate. It's actually, you could just take the knob off, and then you can raise and lower the Z-axis by hand. And what you'll do is you'll notice there's a gap on the side, on each side of this, well, I call this a Z-spacer, basically, and this is what the build plate knob attaches to. And so what you want to do is, you can see there's these 3 screws here, and in between the Z-spacer and the Z-arm is rubber washers. And the reason those are there is so they can compress, so that the Z-spacer can change orientation independent of the Z-arm. And the way you do that is by tightening these nuts. It's just a standard 3-point leveling system. And the idea is that you want the gap between the Z-arm and the build plate, when the build plate is let, when you let it fall loose, you basically want to even up all the gap, ideally. And then when you set the Z-arm down so that it's flush around the perimeter of the spacer. So
Okay, there seems to be a little bit of a gap there.
definitely. Are we going to print?
No.
Oh, okay. So and so what's interesting is, you know, like there's sort of this debate in the printer world where you're sort of incorrectly using the term leveling, right? It's like, well, did you level the print bed? And you're not actually leveling it, because it doesn't really matter if your printer is level. It's just that your axes need to be parallel, and so I guess the term that's appropriate for that is called tramming. So you actually want to tram your axes. And on your LittleRP, what you're actually leveling is you're leveling the build plate in relation to how level the build plate was when you poured the silicone coating in it. So you can imagine that if you had your dish and it's tilted and you poured your resin in, then it's gonna, then then the bottom of your build plate is going to have a slope. And so, which you could still print with, you just need to level your build plate to how it cured. So the best practice is to try and when you pour in your replacement PDMS liquid, to do it on as level of a surface as possible. And part of the reason for that is these Petri dishes, there's no real defined orientation of them. So you can imagine like a Form 1 that's a square and it only goes in one direction. If you cured that off, or if you poured your silicone coating in and it was not level, but you still adjusted your head, like that would be fine, because every time you put it in, it would match up correctly. But the Petri dishes can rotate. So if you had a high side and you rotated it, well, the high side's moving around, and so it's no longer matching the levelness of your build plate. So you could do a couple things. One, you could maybe you could just mark the center of your Petri dish, you know, with like a black mark, and then you'd always know like which orientation was in. Like if you had problems with that, I think that, at least for me, if you add the silicone coating on a level enough surface, you can rotate that dish all day long, and it's not really going to matter.
And I did it for Form 1, and I had bubble levels, and then I had screw adjustments, so I could get it within.
What I use, that's kind of easy, because a lot of tables like at home have bows in them or aren't really level. What I just do is I buy a piece of like scrap glass at the hardware store, and then you can put a little shim under it, and then just use a level. And so you just have like a little surface that's level. You don't necessarily have to have a whole table that's level to do it.
Yeah, well, for some reason, on one of the furniture pieces, I have something with adjustable feet, so that worked out great, because it's a flat plane. I put a piece of glass or something on top of it, and then I can move the feet, and everything is calibrated.
Yeah, well, it's funny. So originally, when I ended up having to buy some extra furniture to do the assembly for LittleRP and things, basically store all the stuff that I had to buy. And so I bought some tables from IKEA, like these like standard, you know, you like screw the legs on, and because I just needed some work surface. And I leveled the table, and I poured some dishes, and then I was looking at the ones on the edge, like were visibly not level, and it's because the table itself was bowed, even though you know my level in the center was fine. Yeah, overall it was level. Yeah, exactly. Whereas you know if a sheet of glass or something is, or if you have like granite countertops or something, they're probably level. But
well, I'm about to turn into a pumpkin.
Yep, I think we better close it.
So it's been a great ride, and I'm sure this will not be our last stop with Brad Hill. He's definitely.
It's looking like this is part 1 of a 20-part series.
20-part.
It'll be great. So we really appreciate you coming on the program and coming all the way down here from Santa Barbara and joining us in studio. And we obviously thank Steve Hernadez also for joining us.
Yep,
and
it was really good.
We will see you.
I think the 2nd of January, or maybe even 9 days after that. Maybe.
So we're going to take a little all things 3D break, a
Yes.
little vacation, go do a little holiday vacations with our family.
You're gonna take a whole year off.
We're gonna take, fractionally.
And thanks again to all our listeners. We couldn't do it without you, and we really appreciate all your support, and hope that you are getting as much out of this as we are, because we
always get something out of it.
We always get something out of it. So we will see you next year on All Things 3D.
All right. Bye. Hold it.